Okay, guys, so we're doing AV Evasion's shellcode, and we are moving on to task 5, generate shellcode. Okay, so I'm just going to read through this. In this task, we continue working with shellcode and demonstrate how to generate and execute shellcode using public tools such as Metasploit Framework. Generate shellcode using public tools. Shellcode can be generated for specific formats with a particular programming language. This depends on you. For example, if your dropper, which is the main exe file, contains the shellcode that will be sent to the victim and is written in C, then we need to generate a shellcode format that will work in C. The advantage of generating shellcode via public tools is that we don't need to craft a custom shellcode from scratch, and we don't even need to be able to be an expert in assembly language. Most public C2 frameworks provide their own shellcode generator capability with the C2 platform. For example, this is so convenient for us, but the drawback is that most, or we can say all, generated shellcode are well known to AV vendors and can be easily detected. We will use the MSF Venom on the attack box to generate a shellcode that executes Windows files. We will be creating a shellcode that runs the calc.exe application. So here we have MSF Venom, x86 platform Windows exe. Okay, so we're running the calc. All right, so what I'm gonna do is I'm just gonna open up my terminal here. Come over here, go to my desktop. There we go. And I have a folder here called shell, I believe. Shell, where are you at? Here we go, shellcode. And I'm just gonna need to name this one generate shellcode. And then I'm gonna go into that folder, open up the terminal from here, and then I'm just gonna paste in whatever they have. Go over here, paste it in, run it, and then it should generate that shellcode. Okay. As a result, the Metasploit framework generates a shellcode that executes the Windows calculator calc.exe. The Windows calculator is widely used as an example in malware development process to show a proof of concept. If the technique works, then a new instance of the Windows calc pops up. This confirms that any executable shellcode works with the method used. Shell injection. Hackers inject shellcode into a running or new thread and process using various tools. Shellcode injection techniques modify the program's execution flow to update registers and functions of the program to execute the attacker's own code. Okay, now let's continue using the generated shellcode and execute it on the operating system. The following is a C code containing our generated shellcode, which we will inject into memory and execute the calc.exe. On the attack box, let's say the file in the file name calc.c. Okay. Okay, so we're just gonna make a file, right? And this C# or C programming language code that we created will open up the calculator, but we need to create a folder, create a file in here called calc.c, which we'll put this into as our little program. Oh, and then lately I've been having issues transferring my like copy pasting certain types of things from here to my attack box for some reason. I don't know why. So what I've had to do is I've had to kind of split it up. If Maybe, I don't know if it's just an issue with my clipboard or something. Let me just copy this, see if I can paste that in. Yeah, see, it's not letting me. So weird. Okay. But I could copy, I'd probably copy this over. Yeah, see, it lets me copy that. I wonder if it's just like Windows Defender blocking it or something. I'll just copy these lines right here. I'll just have to kind of like backtrail. Nope, nope, it's not taking it. Okay, so in order to circumvent that, I guess what I do is I just save it. So I'm just gonna save this and transfer it over. All right, so I just moved it over to this folder here after having to transfer it. Get that out of the way. This. All right. Now let's compile it as an exe file. All right, so I have my shellcode there. I'm just gonna copy their code so we can use GCC to compile this into an exe file that we can utilize. So come over here, throw that in there, run it. Oh, whoa, what's going on here? Looks like it's not taking the command. Okay. Command not found. GCC. Huh, interesting. Okay. Let's see if it just works like this, if I don't have to just do GCC in there. Okay, let me take a look at my shellcode. Maybe that's something crazy going on here. Oh, include Windows H. Let me see. Windows H. That's a comment. Shouldn't matter. All right, so I have to look into this. All right, so I looked it up. It might be I need to install it, so I'm just gonna copy this here, and I'm gonna try installing it, see if it works. Okay, might have to run this as sudo. All right, it's running. It's doing something. It's doing the matrix. All right, just wait for it to finish, I guess. All right, I guess it's finished. Let's see if it works. I always have to be careful whenever I do that type of stuff because I never know when it might just mess up my VM. Yes, it worked. Perfect. All right, guys, so I'll paste this command into the description. So if you guys want to install it, you guys can without having to go to this kind of shady website. I don't know. I'll put the website as well in there, just in case you want to go to the shady website. Okay, I'm gonna close that. All right, so let's see here. Once we have our exe file, let's transfer it to the Windows machine and execute it. To transfer it, you'll need to use SMB client for your attack box to access the SMB share at blah, blah, blah. Tool with the following command. Remember, the password is dimmed. Okay, gotcha. So we're using SMB to easily transfer it. Okay, I'll do it. All right, and I'm gonna open up Remina, my favorite RDP tool. And before I do that, let me just make sure I actually have it, because I don't. Yeah, it's generated. Okay, cool. And oh, they provide you the password and everything. Okay, cool. So we're already in this directory. It's best to, if we're gonna do the SMB, to do it from here and not open up a new terminal, because then we would have to navigate to that file. It's the 107.133. Okay. Tools. Oh, wait, this isn't tools. Wait, tools? Tools. All right, yeah, sure. Is that, I wonder if that's a file we have to make. Let's see. Password. Password for work group. Okay, password 123. All right, 321. Now let's see if it lets me in. No, that didn't work. Should IP is good. Okay, let me look at this. Make sure you got this correct. SMB client. Odd. It's not working. Connection failed. All right, let me try it. Oh, this is my fault. I totally forgot to connect to the VPN. I was in such a rush, I forgot to connect to the VPN. Can you believe that? All right, I'm connected to the VPN now, so now we'll go ahead and give it a try. But before I do that, one thing I always like to do is just ping it to make sure I'm getting a connection. All right, getting a connection. All right, cool. So now we can, oh, snaps, that's not machine. Then we could go ahead and run it. Password 321. Awesome, I'm in. This should copy your file in the tools. This should copy your file in the tools. Okay. Put. All right, so we're gonna use put. Same as FTP. Put MSF dot. Great. That's what we named it. Yeah. While your own machine AV should be disabled, feel free to try and upload your payload to the Vim antivirus check. That's this. Okay. From Chrome, drop it in there, paste it, and we'll try to upload the file. Oh. Desktop shellcode generated. Okay. Desktop shellcode. I need to go to desktop. Shellcode, and this is it right here. We'll open it, upload, and then the antivirus thread is found, and it's determined that this is from a Metasploit payload. So we were caught. All right, and we can already P into that. So this time I just use the IP address. All right, and they gave us the password here. Okay, I'm just gonna click here. All right, so here's the machine here, and we've uploaded via SMB, so it should be in the tools here. So go to this PC, see tools, and we can see it right here. So I'll just copy that. I could actually just run it, just double click it. Should open up the calculator. Yep, and there's the calculator. All because their antivirus is disabled. The Metasploit framework has many other shellcode formats and the types for all your needs. We strongly suggest experimenting more with it and expanding your knowledge by generating different shellcodes. Okay. In the previous example, shows how to generate shellcode and execute it within a target machine. Of course, if you can replicate the same steps to create a different type of shellcode, for example, a Metasploit framework code, generate shellcode for exe files. Shellcode can also store in the bin file, which is a raw format. In this case, we can get the shellcode of it using the xxd-i command. C2 framework provides shellcode as a raw binary file .bin. If this is the case, we can use the Linux system command xxd to get the hex representation of the binary file. To do so, we execute the following commands: xxd-i. Let's create a raw binary file using nsvenom to get the shellcode. Okay, creating a raw file and run the xxd on the creation file. Interesting. If we compare the output with the previous shellcode created with Metasploit, it matches. Nice. All right, so we could try it. It's really just going to give us the same thing. So I'm just going to copy that. And it looks like it's going into the temp example bin. That's not exactly where I wanted to store it. I would want it to store it in the directory I'm working in now, so I'll probably change that output a little bit. So I'm gonna open up another terminal here. Oh, whoops, it's the wrong one. Open up another one here, terminal. And then I'm going to do pwd, print working directory, got my directory, I'm gonna paste in the command. That's not the command I wanted. Paste in the command, this command. Come on, all right, there we go. And I'm gonna drop it in there. And then I'm gonna change the raw, I'm gonna change the output folder to be the folder I'm currently in. So copy my current folder, come over here. Instead of it putting in the .bin, which I don't want to, I'm gonna paste it here. All right, run it. Is a directory. Yeah, isn't that what it's supposed to do? .bin. Okay, maybe I'm not understanding this correctly. Okay, so let me just grab this. I don't think it's gonna work because I don't have an example .bin. Maybe I'm not understanding this. Okay. Let me try going over to my temp folder because I guess that's where it's gonna go. That's what I'm guessing. Temp. There it is. Okay, so that's the example.bin. And then we can run this here. Because I mean Linux can do this apparently. So you can see the output there. It's supposed to match. Looks like it matches. Correct. All right, task 6. Okay, task 6 is a little bit long, but that's okay. Stage payloads. In our goal to bypass AV, we will find two main approaches to deliver the final shellcode to the victim. Depending on the method, you will find payloads are usually categorized as stage or stageless payloads. In this task, we'll look at the differences in both approaches and the advantages of each method. Stageless payloads. A stageless payload embeds the final shellcode directly into itself. Think of it as a package app that executes the shellcode in a single step process. In the previous task, we embedded an executable and embedded a simple calc shellcode making a stageless payload. Attacker, listener, reverse shell. So we are then able to interact with the victim. Stageless payload exe uses stageless payloads. Final shellcode, reverse shell. Okay. Okay, so this is reverse shell connects to our listener. Okay, gotcha. In the above example, when the user executes the malicious payload, the embedded shellcode will run, providing a reverse shell to the attacker. Stage payloads. Stage payloads work by using uh, intermediary shellcode that acts as the step leading to the execution of a final shellcode. Each of these intermediary shellcodes is known as a stager, and its primary goal is to provide a means to retrieve the final shellcode and execute it eventually. Okay. Well, there might be payloads with several stages. The usual case involves having two-stage payloads where the first stage, which we'll call stage 0, is a stub shellcode that will connect back to the attacker's machine to download the final shellcode to be executed. Okay, so victim stage payload uses executable file, connects, retrieves final shellcode. Attacker's machine, payload server, final shellcode, stage 0. Okay. Once retrieved, the stage 0 will inject the final shellcode somewhere in memory of the payload's process and execute it as shown here. So, stage 0. Step 3, load and execute final shellcode in memory. Sends reverse shell to listener. Okay. All right, so first the user executes the payload, which will have a stage 0 sub, which will then connect to the payload server and retrieve and actually connect to the server and stage 0 sub, I believe. And then from there it will load and execute stage 0 sub, which will then run this final shell code, which will set up the reverse shell from the victim to the attacker's machine. Stage versus stageless. When deciding which type of payload to execute, we must be aware of the environment we'll be attacking. Each payload type has advantages and disadvantages, depending on the specific attack scenario. In the case of stageless payload, you will find the following advantages. The resulting executable packets are all that is needed to get our shellcode working. The payload will execute without requiring additional network connections. The fewer the network interactions, the lesser your chances of being detected by an IPS. If you're attacking a host with a very restrictive network connectivity, you may want your whole payload to be in a single package. For stage payloads, we have small footprint on disk. Since stage 0 is only in charge of downloading the final shellcode, it will most likely be small in size, The final shellcode is embedded into the executable. If your payload is captured, the blue team will only have access to stage 0 stub and nothing more. The final shellcode is loaded in memory and never touches the disk. This makes it less prone to be detected by AV solutions. You can reuse the same stage 0 dropper for many shellcodes, as you can simply replace the final shellcode that gets served to the victim's machine. In conclusion, we can't say that either type is better than the other unless we add some context to it. In general, stageless payloads are better suited for networks with a lot of perimeter security, as it does not rely on having to download the final shellcode from the internet. If, for example, you are performing a USB drop attack to target computers in a closed network environment where you know you won't get a connection back to your machine, stageless is the way to go. Stage payloads, on the other hand, are great when you want your footprint on the local machine to be reduced to a minimum. Since they execute the final payload in memory, some AV solutions might find it hard to detect them. They are also great for avoiding exposing your shellcode, which usually takes considerable time to prepare, as shellcode isn't dropped into the victim's disk at any point as an artifact. Stagers and Metasploit. When creating payloads from MS Venom or using them directly in Metasploit, you can choose to use either stage or stageless payloads. As an example, if you want to generate a reverse shell, you will find two payloads exist that purpose with slightly different names. Notice the underslash versus the backslash or forward slash after the shell. Okay, so stageless payloads, they'll have an underslash right here, and then stage payloads will have a forward slash. So sorry. This can be pretty useful. Majority of the time, I think for CTFs, you might want to just go with stageless because it's just a one-shot, drop and you have a shell. You will generally find that the same name patterns are applied to other types of shells. To use a stageless interpreter, for example, we would use the Windows /x64 /interpreter / reverse / TCP, rather than the Windows /x64 /interpreter / reverse / TCP. See how that slash right there? I'd much rather go with this first one because it's stageless. Creating your own stagers. To create a stage payload, we'll use a slightly modified version of the stager code provided by this person. The full code of our stager can be obtained here, but is also available in your Windows machine in the tools CS file stage payload CS. Okay. Full payload code, click to read. The code may look intimidating at first, but it is relatively straightforward. Let's analyze what it does step by step. Okay, let me click this link here. Okay. I'm gonna copy that. And I'm going to put that in my folder. Put that in my toolbox. Make me a folder. New document. What should we name it? What's the name of this? Stage payload.cs. Okay. just gonna paste the code in. Oh, of course, I'm having issues with that. Okay, I'm gonna try it one more time. Yeah, all right. Let me just log in to try hack me using Google from the attack box. Okay, let me just move this around a little bit here. All right, so I have it on my attack box now, so we don't have to deal with any of those copy paste issues I was having. Should have done that earlier, to be honest with you. Goes task 6 here. Click here, get the code. Right, copy that. Put it here, paste it. Come here, save it. All right. I'll put the code right next to this, so I can just kind of read it and look through it as I'm looking at it. There we go. Get this over here. Let's expand the screen out so we get some more screen revenue here. There we go. Okay, looks good. Get this over here. Nice. So the Windows API function, virtual allocate, allows us to reserve some memory to be used by our shellcode. Create thread creates a thread as part of the current process. Wait for single object. Use for thread synchronization. It allows us to wait for a thread to finish before continuing. The part of the code is in charge of importing these functions is the following. Okay. So we're importing these functions here. And you can see it's got some URLs to import those functions, like the virtualc that it mentioned. Part of the code in charge. Okay. Let me scroll down a little bit. The most significant part of the code will be the stager function, where the stager's logic will be implemented. The stager function will receive a URL from where the shellcode will be executed, will be downloaded. The first part of the stager function will create a new web client. Okay, so here's the first part. Object that allows us to download the shellcode using the web request. Okay. Before making the actual request, we will overwrite the server certification validation back method in charge of validating SSL certificates when using HTTPS requests so that the web client doesn't complain about self-signed or invalid certs, which we will be using in the web servers hosting the payload. After that, we will call the download data method to download the shellcode from the given URL and store it in the shellcode variable. Okay, so here's the WS download data URL. This is the URL up here. Or actually, download URL. Oh, here's the URL. So we're gonna have to adjust this. It's saying to input your attacker IP. Shellcode bin. Got it. All right. And shell bytes. All right. Once our shellcode is downloaded and available in the shellcode variable, we will need to copy it into an executable memory before actually running it. We use the virtualc to request a memory block from the operating system. Notice that we request enough memory to allocate shellcode length bytes and set the page executable read-write flag, making the assigned memory executable, readable, and writable. Once our executable memory block is reserved and assigned to the code attribute variable, we'll use the Marshall copy to copy the contents of the shellcode variable into the code address. Okay, so that's what all this code is doing up here. Now that we have a copy of the shellcode allocated in the block of executable memory, we'll use the createThread function to spawn a new thread on the current process that will execute our shellcode. The third parameter passed to the createThread points to the code edge, okay, where our shellcode is stored, so that when the threads start to run, content of our shellcode as if it were a regular function, the fifth parameter is set to 0. Here, okay. Meaning the thread will start immediately. So it'll start immediately. Got it. Once the thread has been created, we will create the wait for string object function to instruct our current program that it has to wait for the thread to execute to finish before continuing. This prevents our program from closing before the shellcode thread gets a chance to execute. So hey, wait for that to finish executing. To compile the code, we suggest copying it into a Windows machine as a file called stage-payload.cs and compile it with the following command. All right, so then we use this to compile it. Okay, so this is cool. They haven't told us to change that out, or maybe I wasn't paying attention, but I don't believe they did tell us to change that out yet. So I'm looking at it and I'm thinking we're gonna have to change that before we do anything with it. Once our payload is compiled, we will need to set up a web server to host the final shellcode. Remember that our stager will connect to this server to retrieve the shellcode and execute it in the victim's machine in memory. Let's start by generating a shellcode. The name of the file needs to match the URL in stager, which is shellcode.bin. Is that what we're creating here? Okay, so we'll run this. Export. Yeah, shellcode.bin. Note that we'll be using the raw format of our shellcode as stager. We'll directly load whatever it downloaded into memory. Now we will have a shellcode. Let's set up a simple HTTP server. First, we'll need to create a self-signed certificate with the following command. Okay. You will be asked for some information. Feel free to press enter for any of the requested information, as we don't need the SSL certificate to be valid. Once we have the SSL certificate, we can spawn a simple HTTP server using Python 3 with the following command. Okay, then when we spawn HTTPS, nice. I haven't used an HTTPS before. I used HTTP so far, but HTTPS, I'm gonna put this one in my notes for sure. With all this ready, we are now ready to execute our stager payload. The stager should connect to HTTPS server and retrieve the shellcode.bin file to load into memory and run it in the victim's machine. Remember to set up a netcat listener to retrieve the reverse shell on the same port specified when running the MSF Venom. And then I'll just see if we can answer some of these questions. And do stage payloads deliver the full content of your payload in a single package? Stage does. In a single package. Stage. No, Stageless is all in one shot, right? And then staged. Staged. Maybe I wasn't paying attention. All right, let me scroll up here. Yeah, so Stageless is able to get it all in one shot. Yeah, so Stageless requires let me read this. Stage payload. Oh no, well, never mind. So stage payload's all in one shot. Right? Stageless is all in one shot. I think. Let me reread it. A stateless payload embeds the final shellcode directly in itself. Think of this as a package app and executable in a single step. Yeah, so stageless is in one single step, one shot. Stageless. Staged, yeah, stages. So, it's a staged approach. So stageless doesn't have multiple stages. So a stage payload has multiple stages. So that's nay. Got it. Is the Metasploit payload a stage payload? So this one doesn't have a /, and because it doesn't have a /, I believe that's gonna be a stageless. But let me check. Oh, it does have. Wait, does it have a / or no? It doesn't have a /. It doesn't have a /. Okay, so it doesn't have a /. So we go up here. It's gonna be stageless because stageless ones don't have /. So that's an A. Is the stage 0 of the stage payload in charge of downloading the final payload to be executed? Yay or nay? Yes. Because the stage 0, you don't even have a stage 0 if you're doing stageless, right? But if you have stages and it's staged and there's multiple like connections going back and forth in order to get your payload on the machine, then yes, that would mean that stage 0 is in charge of downloading it. Follow instructions, create stage payload, and upload it to the DIM antivirus check. All right, let's do it. Let's do it. So we have our code here. We know we have to input our attack IP. So let me just open up a terminal, ifconfig and 0. And you can see I got my IP here. I'm just going to paste that in. And I'm just going to replace this portion here. Paste. All right, cool. And I'm going to save it. And then come here. I'm going to open up another terminal. I'm going to just go here and we will create our Oh, this is for the second. So this is to create this. So they just want us to upload this to the Windows machine so that we can okay. Okay, cool. Let's do this. Let's do this another way here. I don't know if that machine has cert-util, but I'm just gonna use cert-util. I'm just gonna start a Python web server, this one. And then from the Windows machine, move this down a little bit. I'm going to close this out, open up a command prompt, and then I'm going to grab the stage.cs code that we have ready. Oh, here we go. And I'm doing this off to the side, but just give me a sec. I'll pull it up to the main screen right now. Just gotta get everything typed out here. All right, got it. So now I'm gonna copy this, and you'll see the command I was just typing in. One sec. I'm still having trouble pasting things. Okay. There we go. Okay. So now we're just gonna grab it. Grab this. Well, that didn't copy exactly the way I wanted it to. So what I'm gonna do is I'm gonna go here. I'm just gonna type staged payload .cs. CS should download it. Yeah, that's what I forgot to do. I forgot to do the stage payload at the end of that. All right, and I'll put this in the description below. So if you guys want to use certutil to grab the to transfer stuff, you guys can. I prefer it over, Telnet or whatever we're using a second ago. I think we're using SMB, but I just like doing it this way. So yeah, it's on the computer now. Let's check it. Let's go to this PC and stage payload. It should be where this directory is. So it looks like this directory is in the user's dim. And if I go here, you should see the stage payload there. So now we'll follow the rest of the instructions here. And they didn't ask us to do this, but whenever they give me an opportunity to try something, I'm not going to turn away from it unless I'm like super tired and just kind of having a tough time. You'll see me usually just kind of turn away from those. But so far I'm feeling pretty motivated right now. So I'm just gonna go through this real quick. This is generate shellcode. Generate shellcode, stage payload, shellcode, stage payload. This is the wrong one. So, there. All right, so that terminal, let me close that terminal because we're no longer using it. This one, that's my VPN. Let me just minimize that, don't need that. Generate shellcode, yep, this is it right here. I think so. No, wait. No, that's not it. Right, bear with me. I'm just trying to neat things up here because I've gone through two of the challenges so far, and just want to make sure all my relevant. All right, cool. So, whatever. I'll just open up a new terminal. There we go. All right. Okay, so next we need to run this command on the Windows machine in order to compile this. So I'll have to go here, take this. Come on. There we go. So that was the file. All right. So was I supposed to name it something else? Stage. Oh, with the capital S. Payload that. That's probably why it didn't run. It's mine with the capital S. I don't think it matters. This is Windows. Let me do a dir here. Make sure it's here somewhere. Yeah, there is right there. Stage payload. That's yes. tsc staged payload.cs. There we go. All right. dir, and we can see an exe there now. Cool. So next thing we're going to need to do is create, using our stager, we use shell. Okay. So now we're going to create a stager using MSF Venom. We'll put it here. And it wants the attack host IP, which I'm going to input here to 3.84. And what port do we, oh, we don't need the port afterwards. Okay. There we go. All right, so it's going to create that. All right, so we did that. And next thing, we're going to create our SSL cert. This is really cool. And it just puts enter for everything. It's like the who is information for your cert. It's cert information, but our cert's self-signed, so yeah. All right, I'm gonna copy this, paste this in here. All right, and we're gonna serve up our serve this up. Hopefully that looks good. Yep. All right, there we go. I'm using SSL. And we're gonna set up a netcat listener. And then we're gonna execute that executable on the Windows, and that should get everything working. So we could just open up another, I could open up another terminal here. Do netcat. Let's see. 677474. All right, and then from here, what we can do is we can just run the stage payload.exe. So let's do this. And then that should get us a connection if everything works out. If it doesn't, I'll have to check that CS file to see if, hey, we got it. Who am I? All right, we're in. I was really afraid we weren't going to get this. All right. All right, and then it's asking us to upload it. Upload our exe. Is that what we're supposed to do? Follow the instructions to create a stage payload and upload it into the antivirus checker. Okay. Oh, hey. I wonder if we can just start inputting the flag here for challenge 2. Let me check it out. Okay, probably not. I think when we get to this last task, we're gonna have the victim's gonna be AV victim, so I'm pretty sure that's the flag for this one. I'm getting a little ahead of myself here, but and then I guess we'll learn the rest later. But we only have access to THM's account right now, so that won't work. I thought it'd just be pretty cool to do that. And we could upload it, which sure, we'll upload it. Why not? Let me go here. I actually already have it here, so we'll just choose file, shellcode, staged. We'll just send it the CS file. Oh, you can only upload exe files. Okay, so I guess I'll have to come here. Go here, open up Chrome. They have Internet Explorer still. Come on. Any day now, Chrome. Oh my gosh. They must be putting like 2 gigs of RAM in these machines. There we go. Method not allowed. All right, choose file, and we'll choose the file we just uploaded, which is in the users. I put it in them's main folder here. I'll send the exe one up. See if it catches it. I think it's going to catch it. No threats found. You managed to upload your dropper. You'll be executed soon. Get your flag from the desktop. Okay. Odd, because I don't think I had a flag on my desktop. Right? So if I go to CD, I could try AV victim. See if I can get it. No. CD, THM, CD desktop, dir. Yeah, there's no flag here. Okay, I guess we'll just follow along with everything. But this is cool, guys. We just managed to upload this, and it wasn't caught by the THM antivirus checker. Pretty great. This one's going in my notes for sure. So cool, done it. Introduction to encoding and encryption. Okay, so let's see. I can read this one. Oh, this is all reading. Nothing cool here. All right, so I'm gonna read this one, and I think I'm gonna cut this video in half because these videos are getting kind of long, and it's taking a lot of time to render them. So I'm gonna probably have to cut this one up a little bit. But I'll read through task 7, and let me check out this next task. Task 8, yeah, task 8's got some work for us to do. So yeah, okay, that's not too much. All right, so let me just read task 7 for you guys. Introduction to encoding and encryption. What is encoding? Encoding is the process of changing the data from its original state into a specific format depending on the algorithm or type of encoding. It can be applied to many data types such as video, HTML, URLs, and binary files, exe images. Encoding is an important concept that is commonly used for various purposes, including but not limited to program compiling and execution, data storage and transmission, data processing such as file conversion. Similarly, when it comes to AV evasion techniques, encoding is also used to hide shellcode strings within binary. However, encoding is not enough for evasion purposes. Nowadays, AV software is more intelligent and can analyze a binary, and once an encoded string is found, it decodes it to check the text's original form. You can also use 2 or more encoding algorithms in tandem to make it harder for the AV to figure out the hidden content. The following figure shows that we converted the them string into hexadecimal representation and then encode it using base64. In this case, you need to make sure that your dropper now handles such encoding to restore the string to its original state. What is encryption? Encryption is one of the essential elements of information and data security, which focuses on preventing unauthorized access and the manipulation of data. The encryption process involves converting plaintext unencrypted content into an encrypted version of ciphertext. Ciphertext can't be read or decrypted without knowing the algorithm used in the encryption, as well as the key. Like encoding encryption techniques are used for various purposes, such as storing and transmitting data securely, as well as end-to-end encryption. Encryption can be used in two ways, having a shared key between two parties or using public and private keys. For more information about encryption, you can check out the Crypto 101 room. Why do we need to know about coding encryption? AV vendors implement their AV software to blocklist most public tools such as Metasploit and others, using static or dynamic detection techniques. Therefore, without modifying the shellcode generated by these public tools, the detection rate for your droppers is high. Encoding and encryption can be used in AV evasion techniques where we encode and or encrypt shellcode used in the dropper to hide it from the AV software during runtime. Also, the two techniques can be used not only to hide the shellcode, but also functions, variables, etc. In this room, we mainly focus on encrypting the shellcode to evade Windows defenders. Awesome. Is encoding shellcode only enough to evade antivirus software? No. Do encoding techniques use a key to encode strings or files? It uses. Do encoding techniques use a key to encode strings or files? Encode. Yes. Well, it uses, yeah. Nay. There we go. Do encryption algorithms use a key to encrypt strings or files? Yeah, so encryption uses the key, whereas encoding doesn't use the key. Yes, okay. Got it. All right, so, all right, meet me in the next task.